This is 20th lecture in engineering mechanics. So this here we will continue to discuss problems in friction. Now the review of the problem what we discussed last class. It is a problem of tipping and sliding of a block. You are asked to find out at what height the force should be applied such that you get the tipping and sliding to occur simultaneously. If you take a block like this, and if it is say is on a horizontal surface, if you apply a force at the bottom point, you can see it slides. If you apply at the higher levels, it tips. So you have to find out the position at which it both tips and slides simultaneously. So for for convenience, the block width is taken as 2 times b. Now for the sliding to occur, the condition is, if you draw the free body diagram, the force is acting on this R W, which is acting downwards. The P is applied force, and you have a reaction, vertical reaction, that is going to be equal to W, and the friction force is mu times W. So for sliding, P is equal to mu times W, that is the condition. For tipping to occur, when it tips, the contact on the horizontal surface with the floor will be lost. So you can see when it tips, so the tipping is going to happen about this point C. So at that condition, this forces will not come, only you will have a reaction here at C. So if we take moment about that C, then you can see Px is going to produce clockwise and W into B will be producing anti-clockwise moment. The sum should be 0. So P is equal to WB by X. So if I plot these two conditions in a graph, where the x-axis is going to be the x is the distance or position at which you apply the force P, then that can vary from 0 to h, where h is the height of the block. Then I say that for sliding, P is equal to mu times W, that is independent of x, so that will be a constant. So a line will be parallel to this. Then for tipping to occur, you can see that is WB by X. It is some constant divided by X. So it will be a asymptotic curve. It will be going like this. The intersection point is of our interest, where both the tipping and the sliding will occur simultaneously. So that you can see for both to occur, you can equate these two conditions. So X is equal to B by mu. X is equal to B by mu is the point at which both will occur simultaneously. Then you can see divide this region, where in this region what is likely to occur, the force, resistive force which requires least resistance will occur. So here the sliding requires less force, so the sliding will occur in this region. So as beyond this region you have a tipping region. So you have so tipping will occur here in this region. So that is the idea that you can see here. If I go and apply the force at the bottom point, most likely it will slide. So if you go apply at a higher level, it will tip. So the X is the point at which both will occur simultaneously. So that is the problem statement problem that we discussed. Then later on we took another extension of this problem, very useful extension of this problem. The extension of this problem is like you have I want to transport an object from point A to B with least resistance. So how to do that with the least resistance? So what we do is, you cannot, if you try to move from point A to B by sliding, so you will obviously waste energy, because there will be a resistive force and your displacement in the opposite direction. So there will be the negative work which is done. So there will be a loss of energy. So another idea to do that is you can just tip, roll, again tip like this, you can do like this. If you do this way, you are not doing work against the friction force, you can do like this. So that will be reducing the energy. So what we can do is, if we are having a rectangular block like this, the issue is like, the center point. There are two problems with that. Is one is the center position will go up and down. So when you have such a prismatic object like this, it will go up and down, so irregular thing. Then the another problem is that we discussed last class, is there will be an acceleration. When it falls, it will fall with a greater acceleration like this, so the motion will not be uniform. Now to make it little uniform, I can take a regular shape like this and then roll like this. So if I do that, if I start with a regular polygon like a square, I can have a little comfort over that. So I can, by rolling a block of a square block, so I will take, so if I take a square block and a roll, let me show you the problem with that. I can roll like this. So I can say what is the force required if I apply the force through the center. Somehow there I can put a pin called an axle, and through which I apply, and I ignore there is a small pin I provided, because even if it rolls, I should be still applying the force at the center, means there should be a pin called an axle. So a wheel and axle is a standard arrangement. So this the friction in the axle, if you neglect the reactions what is happening here, for simplicity, so you will be applying here the force for a tipping to occur. You can see that you can take a moment about this point. So W is going to act like this. So when it's about to tip, there won't be any contact here, no reactions here. So you will have a W. So you can say that this is X, this is Y. So I can generalize this angle theta. So a theta is going to be 360 divided by the number of sides, half of the number of twice the number of sides, so that will give you the angle theta. So I can find out, for this is going to be 45 here, so I can find out the relation or about moment about this point, that P into Y, that is equal to W into X. So therefore the force P required is W times X by Y, that is equal to W into X by Y is going to be tan theta. That is one thing. The another aspect of it is, when this rolls, the center, this tells you what is the force that is required to the slide a block having a weight W. The another, where the tan theta plays a role. Then if I am talking about the height with which the center goes up and down, because I should not be, when I have a wheel like this fitted on my cycle, I should not be preferring my vehicle to go up and down like this. That is not a comfortable journey. So I have to, if I want to find out what is the height with which the center goes up and down, so that can be, when it rolls, the Z will come here. So from Y, Z minus Y is the height of the center, how much the center goes up and down, that is your Z minus Y. So if I talk about that, the ratio of Z by Y by Z, that is my ratio. Y by Z is going to be cos theta. So my Z is going to be Y by cos theta. So here this 1 by cos theta plays a role. The factor of 1 by cos theta, Y into 1 by cos theta. So Z minus Y is going to be Y by cos theta minus Y. So I take outside Y, 1 by cos theta minus 1. So if I want to use the square, what will be the repercussions of it? If I use the square as my the block to move, so if I have a polygon with the 4 sides to be rolled, 4-sided polygon, the tan theta is equal to, tan theta is computed as this is tan theta 1, and then you have the 1 by cos theta, 1 by cos theta is going to be 1.414. So the meaning is that if you see that if I use a square as my wheel, the argument is I require the tan theta is 1, that means whatever the weight, that is the equal weight I have to apply in the horizontal direction for it to tip. Okay, and the vertical motion will be 1 minus that is 0.414 times the y value is the one which will go up and down. Okay, that is the one it will take. So to reduce this upward motion, so what I can think of is I can, instead of rolling a square like this, I can roll a hexagon. If it is a 6-sided one, what will be the value of tan theta? So 6-sided one, the tan theta value is 0.577. Then 1 by cos theta is 1.5154. So it means that if I use a hexagon, I need only 0.5 times, approximately 0.57 times the weight that is required. So the effort required to roll has come down if I increase the number of sides from 4 to 6. And how much the center goes up and down also has come down. So that is only 0.154 times the height. So you have a benefit if you keep on increasing the number of sides. Say for example, I increase the sides to 24, the value of tan theta is 0.131 and 1 by cos theta is 1.008. That means you see, if I increase the number of sides of the polygon so that it can be rolled, the effort required comes down, the center, how much it moves in the vertical direction also comes down. So that is better. So we can have a benefit of rolling a polygon so that we don't spend much energy, we don't waste energy. So the thing is, why should I stop with 24? I can keep on increasing it. So if I say that is 240, then the 1 by this tan value is 0.0130. Then this 1.0008, 0008. So you see, in this case what happens if I make a polygon with 240 sides and try to roll it, I get a greater benefit, the effort required comes down, I require very least force to pull it. Then the next is I also require the center doesn't move up at all, it is almost staying in this place, that is better. Why do you have a 240? What is the sanctity of number 240? Why don't you make it to infinity? The sides, a polygon with the sides infinity, then where still it will be having the height y, then this will be becoming 0 and this will be staying as 1. That means it is a circle. So that is how the wheel, the circular wheel, has a greater benefit of reducing the force required for your motion. Okay, so theoretically, if you have a perfect circle, the force required is 0, then the center will stay. But you don't have that. You can have it only if you have a perfect rigid wheel sitting on a perfect rigid surface. That is not possible. Whatever be the product, the material that we are dealing will always have some deformation. Therefore, it is not possible to have this option. There will be some deflection at least on the wheel. So we know, we try to make the wheels hard as possible. So that is train wheels. So you can see that steel wheel on a steel rail, so that you have a minimum deflection. Okay, so that when you go for a wheel, circular wheel with a deflection, there is a certain advantage to it. That is, if you have a circular wheel and where the bottom is getting deformed, so you can see this distance is according to us, we have taken this as x. So this is the height. If you say that is y, you can see that the weight is acting like this, the force P is applied here. So automatically what happens is, like, when the circular this thing rolls continuously, this portion is deformed so that the particular bottom portion alone is flat. So the center will remain as it is. There is no the movement about the center because there is a continuous deflection. But the issue is that this is not going to be zero. The force required to roll is not going to be zero. That means what? This there will be some value of tan theta. Otherwise, you have to apply force. So that force what you apply is proportional to x and inversely proportional to y. That means what? If you have a wheel where this y is larger, if I use a large wheel, I have a great advantage. Okay, so where the automobile or the vehicles which requires work on very soft surfaces like tractors use a very large wheel. Okay, so that is an advantage. You use a large wheel. At the same time, this deflection should be small to have a lower resistance. So this will explain you why it is easy to have a hard inflated tire, whereas if your cycle tire is not inflated enough, this length will increase. So greater effort is required. So you have to go and inflate it. So that you can explain the reason for that. This x is called mu roll. The coefficient of friction of rolling coefficient of friction, that is a mu roll, which has the unit of length. So millimeters or centimeters, that we have a length, unless the other coefficient of rolling, friction. So I have explained the other documents. The coefficient of friction sometimes is also expressed as a dimensionless number. Fixing your the wheel radius, etc., it is also expressed. So both are prevalent. So some of the documents use mu roll as indicated without any dimensions. Okay, there you have to follow certain norms to express it. So this is one way of expressing this mu roll. So that is about the wheels. You have any doubt? Because up to which I think we have discussed in the last class. It is just a review of what we discussed. So the idea is to, if you want to have, wheel is one of the most important inventions in the human civilizations. So that is true. Without the wheel, we had to put a lot of effort to move objects from place A to B, because you have to overcome the sliding friction. Now when you talk about the other just simple connected topics, the role of static friction in locomotion. Then we have situations where you have two types of situations, where one situation, wheel, we have a wheel which is driven by an external force. Wheel is driven by an external force. There are there are other situations where wheel is driven by internal torque. Okay, so where do you find them? Where do you find a situation where wheels are driven by an external force, where wheels are driven by internal torque? Not long way to go. Your cycle, the front wheel of a cycle is, you don't have a torque applied, you have a force which is applied. So you can think of the front wheel of a cycle where force is applied for its motion, whereas the back wheel where you can see that there is a torque is applied. You pedal, you crank, so torque is applied here. So how the friction helps for locomotion. How the static friction helps in locomotion, that is the topic to be discussed here. If you think of force P here and the weight of the wheel, that includes weight of the wheel and the passenger or whoever is sitting on it, which is transmitted here. So you will have a normal reaction here that is equal to W, and there will be a static, see this wheel tends to go like this, so your static friction is mu times W, that will be acting here. So if the static friction is absent, what will happen? If the static friction is absent, then you find that there is no rolling possible, it will simply slide. Okay, so you don't have in ice, you have only sledges, no wheeled vehicle will go on ice, so you have to simply slide. Okay, you use sledges for that, whereas if you have a static friction, only then the rolling is possible. Okay, rolling is possible only you have a static friction. In the case of tipping and sliding, the sliding should not occur, the tipping is equal to rolling, so that means the static friction must be high to ensure rolling. So that is why static friction should be high. If it is not high, sliding will be permitted. So whatever force you apply here, P here, it will enable the sliding. So sliding creates energy loss. Whereas if static friction is high enough, so the rolling will be permitted as we discussed. So this is important. So what is the net force which is acting on it? Is P minus mu W. That is the net force acting on the wheel, which takes the wheel in the forward direction. It rolls, but you require a force to move it in the forward direction. That is possible. The net force acting on this is P minus mu W. So without static friction, rolling is not possible. It must be high. That is why we have said that, if you see that in you have a rubber tire on concrete road has a very high coefficient of friction. Coefficient of friction, static friction for that is equal to 1. Okay. Now you take the other wheel, which is self-propelled. You don't require an external force for this. So, say for example, if you take a bullock cart, the bullock cart, it is the externally driven. The bullock gives you the external force straight away for the motion of the bullock cart, for moving the bullock cart. But if you take an automobile, the automobile doesn't have an external force. So all the forces produced are inside the engine. So you can think of this, all the forces are internal. So there is the theorem which says a conservation of center of mass, which says that if the internal forces don't change the the course of center of mass of a system. So it is not possible to change the internal forces don't change the course of a center of mass. That means, like, what to say is, if I am inside a bus, automobile, if I try to push it, sitting inside the automobile, you try to push, everybody try to push the automobile, will it move? It won't move, because whatever you are pushing, there is an equal and opposite, the reaction also that you apply on the seat. So these two forces are internal in nature. So it is not applied from outside. This is an internal force. It won't result in change in the course of a center of mass. So center of mass of the vehicle will stay as it is. So that is in automobile, that is self-propelled vehicles like automobiles or any other vehicles. That is, for example, even you take the ships, or you take the aircrafts, all of them are self-propelled vehicles. So they have engines to produce something, but they all produce an internal force only. According to that, it will not move. But they are all moving. We know that an automobile moves on the road, an aircraft flies, ship the travel in the water, cruise in the water. But how do you say that it is an internal force? The internal forces alone will not propel it. You have to make them interact with some other medium so that the reactive forces are produced. Okay? So reaction forces are responsible for flying your aircraft or propelling your aircraft in the forward direction, or propelling your ship, or even when you walk, this reaction forces are required. For example, if I take an automobile, suspend it, lift the automobile in a crane, start the engine, put the gear, run it, will it move in the forward direction? It won't. Okay, you take an aircraft, put the aircraft in the space. Will the aircraft fly? It won't. But what propels a spacecraft in the air, in the space, is a rocket, not jet engines or propellers. Okay, so for self-propelled vehicles, reactive forces are important. Okay, so self-propulsion, so when it talks about it, self is possible only with reactive forces. The thing is possible only with reactive forces. So this statement yesterday I discussed and given by T. Sudhagar. Okay. Self-propulsion, either it's an automobile or aircraft or anything, even human being, it is possible to move. The motion is possible only with reactive forces. So here, what happens? If I apply a torque here to the wheels, like back wheel of your cycle, you are applying a torque. That torque, if I take a cycle and lift the cycle up, which when the wheels lose contact with the ground, it is not going to move forward. So when the wheel comes in contact with the ground, only the forward motion is possible. So what kind of reactions possible? So here weight W is acting, you will have a vertical reaction, W will be there. Then you have the torque which is acting like this. So the torque tried to move the wheel in this direction, try to rotate the wheel in this direction, so your friction force will be in this direction. and this friction force is mu times W. You can see W's are in the vertical direction, you can cancel. You can see the forward force. In this case, the forward force, earlier case is the force which is moving it is P minus mu W. Here the forward force is nothing but your friction. If the friction is not there, it cannot move. Okay? So the torque is applied, it tries to move, the friction is in the forward direction. You can see the friction here is in the opposite direction of motion when the wheel is externally propelled, whereas if it is self-propelled, then you can see that this mu W is acting in the forward direction. So that is responsible for motion. So here one comment is like it is the forward motion is limited by your static friction. If the static friction is not sufficient enough, it will not move further. You can see that when wheels get into a slushy mud, okay, even if you start the engine and crank the engine, the muds will not be able to give the required friction force. It will churn the mud, so you will not have any forward motion. Okay, so it is possible. So the forward motion of an automobile is limited by the static friction force, right? So this is you can just learn it, and maybe when you really learn your automobiles, this will be really useful. Okay, you can think about it. You have any questions? Yeah, then we will go to the problems. Now we have to quickly do some problems. We will take an interesting problem. Page 56-1. The page 56-1, page 56, problem number 1. What must be, I read the problem, what must be the angle alpha between the plane faces? What must be the angle alpha between the plane faces of a steel wedge? It is a steel wedge used for splitting logs if there is to be no danger of the wedge slipping out after each blow of the sledge. Each blow of the sledge. So what you do is to split the logs. So you can think of this as a log. Okay. To split the log, we use this wedge. You put the wedge and hammer it. So when you hammer, this is to go in. When this goes, when you hammer it, it goes in, but it should not bounce back. Okay? So when you hammer in, after this hammering force is just removed, it should not bounce back. So that is the question, what should be the angle of it? That means this angle is important. If I cannot arbitrarily choose any angle. So that is the problem. So how to find out this, what is required? It's a very interesting problem. It doesn't require much of the mathematics, but you have to have some thinking about it. So what we can say is we have to determine what is alpha. Right? What that all we know is the wedge has some plane surface, then that is interacting with your wood. So there will be reactions coming from the wood, the side surfaces of the wood. So you will have some reaction here, in the absence of friction, I can think of a normal line here. In the absence of friction, the reaction force from this will be like this. So if I say from this one is R1, I can also think of another normal line here, and through which the reaction force from the second thing will come. Now in this problem, what you have to see is, if two forces are acting, they should be in equilibrium, or else their net force should be such that the net resultant force should be acting downwards or trying to push this down. But it is not possible. If that is the case, it will automatically go in. Okay? If these two, the net force is the otherwise, this will come out. So there are three possibilities, like you have interaction of the wedge with the wood log. So the reactions will be coming. So the reaction, if it is such that the net reaction could be in equilibrium, or this net reaction can be acting downwards in this case, so that is also not possible, because if it is downwards, it will try to move whole thing down. There is the other possibility is that forces are, net reaction forces in upwards, so that it pops out. Okay, so if it is to be in equilibrium, then R1 and R2 should be in the same line. But we know that here what we have done is this R1 I have drawn perpendicular to the surface. That is possible only in the absence of friction. So that is not the correct way to do it. So the reaction will be at an angle. When it is about to slip, the reaction will be at an angle of pi, that is equal to tan the friction angle of friction. Okay, but either it will be in this direction or this direction is a question. Reaction will be when it is the slipping is about to happen, when the wedge is about to pop out, it's about to move outwards. The reaction force which will make with a normal an angle of friction pi, but either this way or that way is a question. But if it is then you have to see what direction it is the relative motion would occur. So this is tending to move upwards, so the force that will be applied will be trying to resist it. So this is the possibility. When the motion is upward, this is the possibility. When the motion is downward, this is the possibility. So here, in the absence of the external force that is trying to hammer it down, the friction force will be like this. Okay, so this is not possible. But if I have a friction force like this, and here also like this, there will be a net reaction which is trying to move it downwards. That is also not possible. So the possibility is that if it is in to be equilibrium, the angle should be such that you have a normal here, and the force that is being applied, the reaction force which is acting at an angle pi, should be like this, horizontal, so that here also you will have this. So this is also at an angle pi. Agreed? So that is the concept. So these two can be in equilibrium only if they are in the same direction or collinear. So this is at an angle pi. So when it makes a pi, this R should be horizontal. Okay, so if this is the case, what should be the angle here? That is our question. So you can see that you can construct a line like this. So you have this line. So this is going to be this angle. If I say this is O, this is A and B, this angle is going to be pi. this angle alone is pi, but otherwise I'll say this is going to be, this is 90 and this is going to be 90. So here you have this is going to making a pi with horizontal, therefore this must be making 90 minus pi. If I make this triangle bigger like this, so this is my point A, this is point B, and this is O. So this is my reaction. So this is angle pi, this is angle pi. So this I can make it, this is going to be 90 degrees. So this is going to be 90 minus pi, and this angle is pi. So this is angle is also going to be pi. So it is half angle of the wedge is pi. So the angle alpha between two surfaces will be equal to 2 times pi. So that is the answer to this. So it must be not alpha is equal to pi, it should be alpha should be less than or equal to 2 pi. Why? You have to see that what happens. Okay, if I take for example this is my edge, you look at here, I have this at an angle, an inclined angle like this. Okay, so now it is horizontal. If this is the angle is less than pi, what happens? It goes inwards. So trying to keep it in equilibrium, the net force is acting towards driving it inside. Suppose this is the angle, and then if I go this way, you can see if I go further and further, this is going to act outside. The net forces is likely to act in the upward direction, popping this out. Okay, so you can see that it has to be not only equal to 2 pi, it should be less than or equal to 2 pi. The reason is that the reactions will be downwards, trying to keep this inside the wood block. Okay, so that is that problem. We will take more problems in the next class, that is tomorrow's class.